example 3, we're going to take basically all of the stuff that we've done so far, put it all together, and we're going to talk about different kinds of statements that we can have. So the types of statements that we can have are self-contradictions, which are never true, so they contradict themselves, they're never true. You can have a tautology, which is a statement that is always true. And then you can have a special type of tautology called an implication. So an implication is a conditional, an if-then statement that is always true. Any other kind of statement, a conjunction, a disjunction, a biconditional, any of those that are always true are just called tautologies. Otherwise, if it's a conditional statement and if-then, you do call it an implication. So in example 3, we have P if and only if Q and P if and only if not Q. It looks kind of complicated, but really it's just, I think, those biconditionals that kind of take up a lot of space there. We still only have the 2 letters, and so we would say 2 squared is 4, and so I have my 4 rows. And then I can go and cut in half. Half of them are true, half of them are false, and then I cut each of those halves in half, and I've got half true, half false, half true, half false. Now I just need the negation of Q. So negation of Q, I'm only going to look at the Q, and I'm going to do the opposite of that. So false, true, true. And now I have my if and only if, my biconditional. So again, they both have to be the same in order for it to be true. So in the first biconditional, I'm comparing P and Q. So we're looking here. Those are both the same, so that's true. Those are not. That's false. Those are not. False. And those are the same, so that's true. And now I'm looking again biconditional. This time I'm comparing P to not Q, so be very careful with this one. I want P, so here, and not Q here. They're not both the same, so that's false. I want P here and not Q here. Those are the same, so that's true. I want P and not Q. Those are the same, so that's true. And then P and not Q, those are not the same, so that's false. And then for my complete entire statement, I need both of these to go together. So again, just so you remember, true and true equals to true. So I'm comparing these two, and I need them both to be true, and actually none of them are true, so this is false, 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 false. So in this case, since they are all falses, you would just say my statement is a self-contradiction. And then you would be done. So again, self-contradiction is just a special type of argument that's always false. So in example 4, this one looks less complicated, but it's got more letters, so that means we're going to have more rows. So I do have 3 letters, so I'll have 2 to the 3rd, which makes 8 rows. So 1, 2, 3, 4, 5, 6, 7, and 8. Again, I do this the same. I cut it in half. The first half is true. The second half is false. Then I cut each half in half. Again, half true, half false, half true, half false. And then I cut each of those halves in half one more time. And half true, half false, half true, half false, true, false, true, and false. Now I can actually start comparing things. So the first one is a conjunction of P and Q. So again, true and true equals true. I'm looking at these two. For an and, I need them both to be true. So they're both true on the first one. They're both true on the second one. And that's the only two, so everything else will be false. Now I want P or Q. So again, this one is false or false to be false. So I'm comparing still P and Q. And we'll go down here this time. but this time I want or, so both falses, right? If I start at the top, none of those will be both, and so I just get these last two that are both false. Everything else will be true. And then for my last column, this is my conditional, my if-then. So again, so remember, true, then false, equals to false. I'm just comparing the two statements I just did. Ooh,